Okay, great. So what we're going to be doing today is a little bit of SQL review, but also just walking through kind of the basics of this example problem, and then maybe the first query of the 10 you're going to be graded on, and just show you what like the flow of it is like. So we're going to start here. This is the link that I shared on Slack. If you don't have this link, get in touch, but it is on Slack. This is the link to take the assessment. So I'll put that in my browser. And if you're in the class, it should recognize you and or you choose from these identifiers. I'm not in the class technically, so I'm just going to click this. It's confused because let's try that again. There we go. It was confused because I deleted my own copy. So I could show you this. Okay, so I accepted the assessment. And we're going to wait a minute and then refresh. Great. So it's ready to go. I click here. So just like all the assessments, this is in the GitHub org called Uniform Platoon Assessments, or assignments, just like all your assignments, actually. And we have assessment to dash my GitHub username, which is aloof Buddha. And just like any other one of these assignments, I can click code. This is what I use, so I'm going to copy paste that. And then I'm going to go into my terminal here. And I'm already in the folder I want it to be in. So I'm just going to copy paste that. And I clone it locally. And I guess right now I should go into SQL assessment answers. No, we're going to go into assessment to aloof Buddha. I can see the file structure here, but I'm just going to open it in Visual Studio Code so I can work from there. Okay, so maybe I'll put it over here because we might also want to look at some PSQL stuff. So the first thing I can do is I'm going to look at the README. And I see for this assessment, you will utilize everything about SQL, etc. We're going to be working with CSV files. 70% is the cutoff I see. And then there's some penalties around submitting late. All sort of standard stuff. And then we have some requirements here where we're just saying this is going to be the name of the database. These are going to be the tables in the database. And I have some explanation here about the flow, which I'll just walk us through right now. But first things first, we want to create that database locally. Then we're going to update create schema.sql so that we can, create an actual database. And if we click on that, we'll see that in create schema.sql right now, there's already something in there. So there's already some code in here. And this is code that we want you to utilize. You might have to, modify it a little for these other cases. But this is the code that is going to get us our examples table.
Hey, Ben.
Yes.
Just a quick question about this part right here with the, so we're taking the data from the CSV and we're putting it into our database tables. This seems like a method I don't remember. Have we used this method? I think last time we used psycopg to insert data from.
Yeah, you're absolutely right. In the past, we used psycopg to work with CSV files. Turns out there's a built-in way to work with CSV files directly from SQL. This isn't something you're going to have to modify too much. You're going to be able to copy paste it exactly. I apologize that we didn't teach this, but this is one of those things where, unfortunately, there's still some work we're doing on the curriculum such that we'll teach the whole module, and then we get to the assessment, and I realize, oh, the assessment uses something we didn't teach. And that's not ideal, but that's why we're having this right now and why we give you an example of it directly. But there's nothing you're going to have to do with this that's too complex. You'll basically just be able to copy paste it exactly.
So it actually sounds like it's easier than the way we were taught.
Yeah, this is much easier. Exactly. It's a way of working with CSV files and SQL when you know that the CSV, the names of the columns in the CSV file are identical to the columns in your SQL, which is going to be possible because we're going to be creating it ourselves. There was another question?
Is this going to be like purely SQL, or will we be using any type of extra installs like scicop or anything like that?
Not using any Python, any scicopg. This is purely SQL, and we're going to walk through exactly what is expected of you.
I had
Okay.
a question about that because we never went over the backslash copy.
I know. Yeah. I apologize for that. When I saw the assessment earlier this week, I have not seen this assessment before because I didn't teach it last cohort. I didn't know that we had this in there. It seems like we should definitely be teaching this during the module, but this was in there and this is how we do it. And you're going to be able to just copy paste this. So I'll show you exactly how it works now.
Okay,
Benjamin,
but if we did use Python, we could just construct it with Python and it wouldn't even know, right?
Exactly. Yeah. So it really doesn't matter how you get the data into the database. You could even write, individual insert intos. This is just a way we're going to do this that's, simpler.
Okay, thank you.
But yeah, what you're tested on ultimately is not this. You just need to get the data from the CSVs into the tables. And then from there, what you're tested on is running queries. Okay, so there's more in here in the README about like what the sort of flow we expect from you is, but it's what I'm going to walk through right now. So before looking at the sample output stuff, we're just going to go back to create schema. And from my end, I'm going to drop the DB I already created because we want to recreate it, right? So this database doesn't exist anymore. If I try and said PSQL, ASMNT2DB, it does not exist. So looking at the README, the first thing we ask you to do is make a database with this name. So we're going to do this together. Can anyone tell me how would I create a database with this name?
create DB.
Exactly. So we have a top level thing in our terminal, create, and I like using tab because it lets me know what's there. Create DB is right there. I'm going to name it ASMNT2 underscore DB. So that's the name of our database. And now let's just try going into it. So we'll say, ASMNT2 underscore DB. Obviously, if you're on Windows or Linux, this might be a slightly different command, but we're just going to go into the database. And then from there, how would I see what's in this database? Like I want to see all the tables, right?
/D.
Yeah, so /D. And it looks like there's nothing in there, which makes sense because we just created it. So I'm going to exit out, /Q. Cool. So I have this table, I have this database, but ultimately I want to put things in the database. So let's look at what the example code is, which you're already given in create underscore schema.sql. So first we're saying drop table if exists example. So if there was a table called examples, we would first drop it before running the rest of this code. And there isn't a table like that right now. But eventually there will be, and then we're first dropping it. And as you create the rest of your tables, because there might be, foreign key relationships, you might want to add like a cascade there. And we wrote as much up here. But for now, for this one, this is enough. So we're going to drop a table if it exists. And then we're going to create a table that looks like this. The table is called examples. And that comes from here. We're saying it doesn't come from here, but this table we're calling examples. The other ones we're giving you exact names, users, items, orders, order underscore items. And we're going to create this table called examples, and it's going to have an ID, which is a serial, so auto incrementing, and it's the primary key for examples. And it's going to have a name, which is a varchar 255, and it's not null. And then here's the interesting part. I have this /copy command. So this is a PSQL thing, not necessarily a SQL thing. That's why it starts with the /. This is something we're going to be able to just copy and paste from saying, okay, /copy, the name of the table, examples, from the location of the CSV relative to where we run this. So given that we're going to run it from the root of the file, we have /data. /examples.csv. And this is what it looks like. And you'll see it has a first column ID and a second column name, which lines up exactly with how we named the columns of this table. And that's exactly how we're going to want to do it. We're just going to look at our CSV and say, these are the names of the columns. These are the names of the columns. And then we give it appropriate types and constraints based on what the data looks like in our CSV and whether it refers to another table or anything like that. And then the rest of this here is with format CSV, delimiter, comma, header, true. That's something we're just going to be able to accept for all of them. So now I'm going to run this code. How would I run this create schema file against our database?
Would it be
/I?
Say that again.
You can go for it, Ethan.
/I, and then,
If we go
oh wait,
directly,
oh, sorry. I was talking about inside your PSQL.
well, that works. We could do that if you'd like. So we'll try both ways. The first thing we'll do is what you said. We'll say PSQL ASM and T2_DB. We'll go directly into that database. And now that we're in here, we're going to go /I, right? And now when I hit tab, it should know about stuff. So I can fill out create schema.sql and hit enter, and I'll run this file. So what did it do? It said table examples does not exist. So it skipped this line. And that's what happened when I tried doing the drop table. So it didn't really drop anything. And then it created this table like this. And then it copied 4 things. So it copied everything in here. And now how would I, well, first, how would I see what my examples table looks like internally, like the schema of it in PSQL?
\D.
Yeah, so \D will, if I do just that, it'll tell me all of the tables it knows about, including some tables that aren't really something I'm going to work with directly. It's a sequence. It's something to keep track of the primary keys. But I could do \D and then the name of the table, and that'll tell me exactly how the table was defined. It's maybe more information than I need, but it should match exactly with the schema we created here. And now if I wanted to see all the values in that table, how would I do that?
You select star from tables or examples.
Exactly. So select star, meaning all the columns, from the name of the table. The name of the table here is examples. And then don't forget your semicolon. That's everything that's in there. And it should match identically to what is in this CSV here. And it does. Cool. So I'm going to exit out of this right now, \Q. I'll clear the screen. So the way we just did it was we went into PSQL, we went directly to that database, and then from in there, we used the /I to write, to run that file. But if you're on Windows or Linux, you might have a little more trouble with that because you're like switching to a different user before you're going to PSQL. And so the way you might want to do it instead is from your terminal, you say PSQL and then the name of the database, okay? And then we use this text redirection operator to say, whatever I put on the right here, pass it into the left as if it's input. So we're going to open that database, and what we're going to put in is this file here, create schema.sql. So I'll run that, and it just did the same thing. It dropped the table because the table existed. It didn't give me that warning. It just actually dropped the table. It created the table again, and then it copied everything from that. It copied everything from this file, the examples.csv, into that table here. And if we looked in PSQL, we'd see it's the exact same. It's the exact same thing. So nothing should have changed. If I say, I can just do up to get it back. If I say select everything from examples, that's exactly what it looks like. So we have our examples. We have our examples table currently living here. And now the next thing I'm going to look at is this run queries file. So run queries is just a helper file. It's basically just going to run each one of the queries in this queries folder over here, one after another. So if I ran it right now, what would happen? Well, I can look at these individual ones and I see for 1, 2, 3, 4, they're all comment. They all are just comments. So 1 to 10 are just comments. Those are the ones we expect you to fill out. And there's a your code goes here thing. But for each one, and this is also in the README, but for each one we have like 0, example query to retrieve all example data. And then we're showing you what we expect the output to be. So the output should look like ID, name, and then all the columns. And then in this case, this is how I get, this table. So to run that, I would do the same thing I did before, PSQL, ASMNT, to_DB, and then I pass into it, instead of create schema, I'll pass into it run queries. And then that runs and I see that output. But that's actually running all of them. And that's going to be useful sometimes. But if you want to run one specifically, the one you're working on, we could just get that back. And instead of saying run queries, we say, okay, we'll go into queries, grab that first query, and just run that code. And we get the same thing. Okay, so that is the basic flow. Now, just to see it working, let's try and do number 1 together. So first we're going to look at number 1, and it says write a SQL query to retrieve the name and email of all users. But of course we don't have a users table yet, so we're going to want to do that first. So really you're probably going to work on create schema first, and you could do it all at once, but you can really do it in order where you look at each query and you say, well, if that query requires this table already exists, let me make it. So let's create, in order to solve this, this thing that relies on the users table, let's actually take this users.csv and turn it into a table right now. And we're just going to give you this one for free, or we're going to do it collectively. So if no one here can get it, then I guess we don't get it for free. So yeah, given that this is our data, we can see it side by side if we want. This is our data. What do we want to do here? We're going to replace this with creating a users table. How do we want to do that?
And drop table if exists for users.
Exactly. So the first thing we're going to want to do is drop table if exists users. And it doesn't exist yet, but because it will eventually exist, we want to make sure we drop it before we create a new table. And now let's create that table. What should I write?
Create table users and then parentheses.
Create table users and then parentheses. And then just so I don't forget, I'll put a semicolon at the end. It's easy to forget that. Right. And now we're going to want to define our columns, right? So what should we define the first column as?
ID.
Okay, ID is the name of it. And what should its type be?
What?
What was that?
I didn't hear what you said.
Oh, what should the type of this ID column be?
Serial.
0 primary key.
Yep, serial. And then in terms of the constraint, the reason why it's serial is the same reason we're going to say primary key, because this is the key that represents a unique user. And it could be, and it is the case, that when we look at some of our other tables, we're going to want to refer to a user by ID. And that is how we refer the user by ID. And the serial thing is just a number that is going to auto increment even if we don't explicitly provide it. Okay, what's after that? What's the next column?
So it's going to be the same as in our other table. So it's going to be name and varchar 255.
Exactly. So we're going to say name and then varchar 255. I'm pretty sure even just varchar would work.
I have a short question about that, I hope. So I was going through what is it? The review examples, and the reviews examples uses text a lot as opposed to varchar. If we use text in the assessment, is that going to break things for us, or?
I don't imagine so, no.
Okay.
Because the only thing our assessment tests is input to output, and as long as it still prints John, whether you save it as a varchar or a text, I think it should work identically. We could even try that. So I'm going to make it text like you said. I think doing text varchar, that's really more to do with implementation details and making sure you're not taking up any more space in the database than you have to. But it's not really essential. So we'll see. Hopefully this works just as well. And then do I want to add a constraint for this one for name?
No.
Yeah, so it's not ultimately necessary because by the nature of the examples we gave you, everything's filled in anyways. But I might as well add a not null, which just means that if we ever gave it a null, it would blow up. Wouldn't add anything to the database. And now let's do the other ones. We have email. What should I make email?
Email field, right? Or
Well,
I think that's only in Django. I
Oh.
think it's just got to be a varchar.
Yeah,
switch tracks here.
so the column name is email, and then the value is just a text. I mean, I don't think there is any special email type in PSQL, so we're just going to name that. You know, we could do varchar 255 text. We're just going to try this text thing out. I'll also make it not null, which I of course couldn't do if one of these was just blank, because then I would have to account for null. But in this case, all the data is filled in. And then finally, created at. What do we want created at to be?
Think
Timestamp.
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 Exactly. So we want timestamp. And yep. Someone said something?
Could it be date time? I'm sorry, I'm just curious if
The thing is, I'm not sure if date time is maybe it would work just as well. Is time a built-in PSQL thing?
With this is a little bit off, but with users, isn't that a keyword? Wouldn't you have to put that in quotes?
Users?
Yeah, is that gonna work? Because it's showing up blue. Wouldn't that be or is it user that's a keyword? I think
It's
users
user.
is a
Because Ethan and I ran into that issue. It's user by itself is, I think, reserved, and then users is fine.
Okay.
okay.
Yeah. No, I mean, users should work here because we've tested this, and it's just, it doesn't have to, but we're making sure that it matches this this table over here. But yeah, created at timestamp should be enough, and then might as well add a not null. But right, this is our data. And if we did this right now, like if I ran this exactly as it is, where I'm running the create schema, it should work. And it says does not exist, but it still created it. And if I go in there now and I say that database, and then I say /d users, it did create the right users thing. But of course, if I said select star from users, I would see no users. So we're going to fix that right now, because we want to add that line where we say, okay, well, now actually go into that CSV and get everything. So how would I want to do that? I'm going to start by copy pasting this whole line, and then we'll just talk about what we have to change. And this will be the same process for all the other tables. So
Change examples to users.
exactly. So we changed the name of the table there. So the first variable, if you could call it that, here is the name of the table. And then what happens here?
Change it in the file path too. It should still be just /data/users because it's in the same like place.
Exactly. And now when we run this, do that like that. Now when we run this, we're gonna make this a little smaller. Oops. Now when we run this create schemas thing, it's going to do the copying too. So we dropped our table because it was there. We created a new table and we copied 4 into it. And we can confirm that by going into PSQL, into the database, and saying select star from users. And we see, yep, it's exactly right. It's exactly that data we expected. Okay, so that is going to be the same process for these other tables. It's just that these other tables might be referring to the users table, and then you might have to write more stuff in terms of like, you know, references and things like that. But that's going to be for you to do. For now, though, let's see how, if we go back here, we can finally do our first query. So the 0 is an example. It's not actually worth any points. But when we ran it, we saw, we were able to run it one of two ways. One of them was like this, run queries, which if we look at that file, it simply runs all the queries. Or alternatively, we could have just run just that first query. And we saw that output, and we see the output that we're expecting to get is identical to the output we actually did get. But this 0 is not worth any points. It's just to show you. So if I look at 1 now, and I'll close this, 1 is asking us to write a SQL query to retrieve the name and email of all users. So what do we want to replace this with? This is what we're looking for, something with name and email. And if we want to do this, sort of, building it up over time, we could actually go in here and I could say something like, okay, select everything from users. Well, it's not quite the table we want, right? So what do we actually want to write here to get exactly this table?
Select.
Yep, so we're definitely doing a select. And I guess we'll build it up. We're just going to put that star there for now. We're selecting everything from users. So now how do we want to modify this to just get this table?
Instead of the star, you just put name, comma, email.
Exactly, name, comma, email. So now I have that. I'll exit out of this. So because my database has already been built up to the level I desire, I don't need to worry about running create schema again. I can just run queries. And if I run all the queries, I'll see I got that first output for the 0th case and this next output for our first query, which is actually graded, and it looks correct. But of course, I could have tested it one at a time. I could have just said, given queries, 1, what do we get? That's exactly what we get. Cool. So we solved the first one, which is something we wanted to do together. Great. So now what I'm going to show you is how our autograder works. So if I open up my terminal here, I'll notice because I'm using something fancy, it's saying like you have 2 things on Git that, are untracked. So I could say Git status. And I see here it says, yeah, you made some changes. How do you feel about those changes? So I'm going to say, I like both of those changes. I'm going to add them in. If I wanted to, I could say Git status again. I see they're ready to add. So now I say Git commit -m, and it doesn't matter what I write here, but this helps me keep track of things. So I'll say submission 1. And then finally, I'm going to push it. And because you check this out from GitHub Classroom, we did it through that. That's all set up already. So now at the bottom here, it's actually pointing you back to that original repo. So I'm going to be able to click that and go right there. Great. And I actually already had it open here, so I can just reload it. And you'll see it says submission 1. Cool. And you'll actually notice there's this little orange dot here. So what is that? Well, you might have noticed this .github file. You don't have to look into that file. We prefer you don't. If you're clever enough to mess with it and cheat that way, I would be incredibly impressed. But the easy path to passing this assessment is not going into that file and trying to mess with it, just passing, the queries. So if I there's this tab here called actions, and clicking this dot would do the same thing, but I'm going to click actions. When I click actions, I'll see, well, there's this initial commit, which is something GitHub did for you, but then here's submission 1. Here's what we just submitted. So I'll click into that. And now it's showing me this job that ran, a workflow, as they call it. So I can click in there. It's called auto grading. And I'll see if I open it up, you can even watch it happen in real time if you're quick enough. It's doing a bunch of things, and you don't really have to look at most of this. We're just going to look at it now. So it's like checking out an operating system. It's doing all this stuff where it's just creating a computer from scratch to do this. It's checking out our code. It's setting up Postgres. So it's downloading Postgres from scratch and setting it up. But again, you don't need to know any of this. Then it's running and loading data with create schema.sql. So just like you ran it locally, we're running this here. So that database now exists according to this job, which is happening on some computer it just spun up. And then here's the part you want to care about, code platoon autograder. So we're going to look in here, and this is actually going to show us each one of our queries and how we did. So in this case, example query, this is what it's expecting. And if you got it right, it just shows you a check, because that means that your input and output were identical. Same here, this was your output, and it's exactly what was expected, so you just see a check. For the rest of them, we get these errors where it says, you know, I expected this, but the actual was nothing. Why is that? Because if we look at 2, it doesn't do anything, it returns nothing. So that makes sense. And if we scroll all the way down, we'll see that we got 1 point on the assignment. So if you get all 10, it's going to show you. And the only thing to remember is that it's always going to count your last push as the final grade. So make sure that you could always, you know, find your previous work through GitHub, because that's what it's there for, to save your commits. But just make sure that when you're done handing in the assignment, which is due Thursday morning, 7:30, I believe, because, you know, we have some time off, so you have a long time to do it. Just make sure that the final commit has, you know, your max number of points for what you've actually solved. And this is how you would see how you did. And actually, if we go back here, you can see it's right up there. So you don't even have to go in there. Going in there is only useful if you want to see the difference between what went right or wrong, but it's going to give you your grades over here. And just to show what it might look like, let's go into number 2. So we solved number 1 correctly. For number 2, it's asking us to write a SQL query to retrieve the name and price of each item. Well, we haven't created the item table yet, and I'm going to leave that up to you to do it. But let's say we just took exactly what was in here, right? So I'm going to say we want to retrieve the name and the price of each item. But let's say I mess up and I say select the name and price, but I'm trying to grab it from users. So what's actually going to happen? I guess I could show this 2 ways. First, I'll do this: name and price of items. And remember, items doesn't exist yet. So if I try to run that locally, which, you know, we can do here. If I try and run this locally, I haven't made any changes to our schema, so I'm not going to run that again. If I try and run this, I get an error. It says relation items does not exist. Select name price from items. It broke right there, items. But let's say I didn't realize that, and I just wanted to push these changes. Gotta get stuff out of the way so I can see it. Yeah, so let's just say I said submission 2. You can name it the same commit over and over again. It's just a little easier to see this way. So I'm gonna push those changes and I'll go back here. So this is the actions tab, and you can see now it knows about this next submission. It's currently running. So if I click, I could actually see it run in real time. I could click in there. And it's actually doing this stuff. It shouldn't take too long, but as you'll see, it takes a minute. Again, there's no expectation you would understand what any of this is doing. I don't really understand what most of it is doing. Francisco wrote this part. Okay, happened really quickly. Let's scroll up. So we see in here, just like normal, it, you know, dropped the tables, created the tables, so it's going to run that every time. It says these tables don't exist because in the autograder's world, it's never seen any of this before. It's working on a brand new computer. But here we see, okay, we got this one right, great. We got this one right, great. This one we got wrong, and we see an error here. So we see the error, but in terms of the expected versus actual, it's still not super useful because we had no output. So let's say we go back here and we say, okay, let's actually get some output. It's just going to be the wrong output. So I'm going to say from users, which does exist. And what is in users? Name and email. Maybe I'll say name and how did we define it again? Users has a name and let's say created at, okay? So I'm going to say name and created at from users, and then we'll see. Of course, we could just run it directly. Let me grab that back here. If we run it directly, did I not save it? I didn't save it. Sorry, I changed the wrong thing, I see. So let me put that back how it was. So that's correct. But for number 2, let's say I did something like this. So that's a table that exists. We're actually going to get some output. And we'll see that here. If I run this, I actually do get some output, but notice that that output doesn't match this output. So that has a name created at, this has a name and price. And also because it's looking at a different table, it has the wrong values. Let's actually see what our autograder sees. So I'm going to do my git add stuff again. So I'm adding that I, changed a file, and I'm going to commit and say submission 3, and then I'm going to push it. And as you can see, you can kind of see how you're doing as you go, because I'll go back here. And this is just the actions tab. And because I have to go all the way back, but if I go to the actions tab, I'll see my submission 3 is running right now. I can click in there. And if we wait, we will see what our results are and what the feedback is. So I'm looking at the comments right now. In terms of 0 example, or I'm looking at the chat. Example query, it doesn't matter. It's worth 0 points. I would leave it as it is, but it's worth 0 points. Okay, so we still just got 1 point because we only have a single thing in there that's right. So the example query is not worth any points. Whereas 1 passes correctly and it is worth points. But now notice number 2. Not only does it tell us our output and does it tell us that it's wrong, but it says we expected this and this is what we got. And so comparing the difference between what it expected and what you gave it is going to give you hints as to how to fix it. So this is there for your sake, just to see what we expected versus what you gave us. This and this will always be the same. So the actual is what prints up here because that's what your output was. And in this case, they don't match and they have to match exactly. Otherwise, it's not going to pass. So putting this to the side right now. That's the basic flow of things. And if we go back to the README, we'll see we say as much where we say, okay, so first you create that database and then update the create schema.sql to actually, create that table you want to work with. And as you move through these, you're going to find you have to make all the tables pretty quickly. Then we're going to run create schema.sql like we saw, something like this. That's actually not right. We want to add a PSQL over there. And then after that, we can run queries.sql, or we could run the individual query like so. Once again, that should be in there. And we want to match our outputs as exactly as possible. And yeah, that's everything. So we're going to do a little bit of review on certain ideas that might be helpful for this, for completing these queries. But any questions on that general flow?
I have a question. I think a few of us were getting like an error about like an extra, where did it just go? Like extra data after last column expected. And I tried looking up on Stack Overflow and it was saying something with like the delimiter that's in like the copy examples.
Interesting. Can you share your screen maybe?
Yes. Hang on a second.
Okay.
Yeah, I got the same thing, and then when I did the select all from users, it just gave me an empty table back.
Interesting. So yeah, let's take a look at that quickly because that would be an issue.
So this, I just kind of like tried taking that delimiter out, but if I save that and then all those. And so I get this here.
Okay, give me a second. So you're working with a users table, right?
Mm-hmm.
And can I just see your users table quickly? The users.csv rather.
Oh, yes, right here.
Okay, yeah. So that looks identical to mine, which is good. And there's no extra lines there. Okay. So then the next thing is you are trying to run this code /copy. So I see here's your issue /copy examples. So you're putting it in the wrong table, and that's where it's getting confused. It's putting data that yeah.
So this should just be users.
Exactly. So we want to put into the users table all the data in ./data/users.csv. Let's try running this now.
Okay, so what we're putting here is the table name.
Exactly.
Okay. Well, I guess I'm going to do a comment here, but. Okay, perfect. Thank you so much.
Well, now let's try running our query. Do you have the query in, or yeah, I mean, in terms of testing it out, you could absolutely just write the queries directly in here. And as Jesse is demonstrating, SQL doesn't actually, it does care about spelling things correctly, but it doesn't care about capitalization. So that capitalization is just there to help you distinguish between what is built into SQL as a keyword and what's not. But right, in this case, we're getting the exact right thing. And do you want to demonstrate for all of us the process of seeing your current grade?
Sure.
Yeah, let's do it.
So I can just git add first.
Mm-hmm. It's always good to check the status first, but I'm pretty sure it's fine. Yep, that's what we want to change, yeah.
And then.
Yeah.
Commit.
Name that message anything, it doesn't really matter. It's just an easy way of identifying it.
And I guess because I'm already on main, it should be good to just.
Yeah, you're going to want to stay on main, yeah, and it's all set up already. So right now we want to go back to that GitHub page, which you might already have open, or you can click on, but there it is. And then you're first going to want to refresh because GitHub doesn't know anything changed. Yeah, and now you see that little orange dot there. Which you
said or actions.
Yeah, if you click directly on the orange dot and then I guess click details, it'll jump right to that page. Yeah, and then here we're going to watch it happen. Cool. And you know, if there was any useful output, you would see it there, and it closes real fast. But if you were to just I mean, you could open it up again, the code Platoon autograder part.
Okay.
And all the way at the bottom, that's going to tell you how many points you got.
Okay, so that one. Oh, very
cool. 10. And then also, if you scroll all the way up on the whole page, so just go back to where it says actions at the very top.
And click on that?
Click on it. So that's going to be your main view. And if you clicked on first submission there, it's going to show you how that run went. And without even clicking into the details, it's going to show you the output, which was points 1 out of 10. I don't want to spoil it, but if you get all 10, this wasn't me, this was GitHub's autograder. If you get all 10, you're going to see some emojis. So that's a good motivator.
Nice. Thank you.
Yeah, cool. So if you stop sharing now, I'll start sharing my screen again. Great. So that's the basic flow of how we expect you to do things. And then all that's left is I have some topics here, things that might be useful to review. Not all these are absolutely necessary. There are different ways of accomplishing this, and we really don't care how you get the output. We just care that you get the correct output in your queries. But these are all topics we might want to cover to some extent. So we can just, keep this to the side and just work in PSQL like so. So I'm just going to go in there, or I wonder if I have other databases that it might make sense to work in. So do I already have something set up with like, if I have Grubhub and I were to say /d, see I have some stuff in there. And if I say select star from orders, yeah, it's not going to be the most useful thing. So maybe we're going to want to go back here, and I guess we'll just go into PSQL as the assignment one. And I guess I can make a dummy table if we want to work with stuff. But here I see I have users and examples. So I'm going to say, select star from users, and that we already know. And we covered this /copy thing. But as a refresher, it's going to look like I'll copy paste it right from the create schema, but that's the only place you're going to use it. And you're just going to be able to copy paste it like that. So returning to this review, it's going to look something like this, where I say /copy. And then this would be name of table, obviously without the, brackets. It's just, we would replace that with the name of the table directly. And then this would be, something like path to file. Maybe I'd even write it like path to file. And that's going to be able to be very similar, and you don't have to change any of the rest of the stuff. So something that's pretty important for this assessment is the as keyword, which we may or may not have seen, but that's just a way to redefine something. So let's say I have something like select star from users, and it turns out I only want the name and the email. And this is what it looks like. But let's say for some reason you're seeing that I'm asking you to return something that looks like total revenue, right? And you're like, what is total revenue? That's not a column in that table. Well, you might have some way of calculating that, but you can change the name of a column always by doing this. So I could say name email as, user's email. And by saying as, now when it outputs the table, this column isn't going to have the column name that it came from. It just changes the name of the column, but all the data is the same. So as is a useful one, and the as can end up being pretty useful when combined with one of these aggregate functions. So, what's a good example? Let's just say I'm going to add, just for the sake of this example, I'm going to want more than one John Doe, right? So I'm going to just make another user called John Doe. I'll say insert into users values, and I don't need to give it the ID, but I'm going to give it a name of John Doe. Actually, I don't think I have to do this because we already have 2 Johns in there. So let's try and make a table right now that tells us the names, or it tells us the count of people whose name is John. So let's write that collectively. First, we're going to start with something basic like name star from users. That works. Select star from users. Okay, that gives us our whole table. But now we only want the people named John, right? So how might I do this?
Select star from users where name, I don't remember the sentence, like is or equals John.
Yes, I think I can do something like where name I think like, so that's one of the things to cover here. There's I like and like. So I like is just case insensitive. But in this case, they both have a name very similar to John. So I'm going to say like, and then in here, I'm going to say, okay, like John, but John might have stuff following it. So I say that to match everything else after John. And if I do that, I see that I got both of those. Cool. Okay, so now that's only the people named John, but I actually want to know the count of the people named John. So now how might I get the count of everyone named John? Well, we can use one of these aggregate functions. And the thing I could do is I could say something like,
Would you select count parentheses name from users, and that would replace the star with that?
yeah, so if I say count star, what happens? Well, that's still just going to give me 2, but I could more specifically say, instead of counting all the columns, I would say count name, right? That works just as well. So I see I haven't come up with a situation yet where we're seeing group by. But these are all keywords in SQL, and group by would be a way of saying, like I think if I took the original thing before I said where name equals John, and I said group by name, then what it's going to do is take that original table and it's going to group people by name. So anytime the names are identical, and in this case, none of the names are identical, but for each name that's identical, it's going to group them together. And then when I say select count of name, it's going to have, I could say something like name and count of name. It's going to be able to combine those. So now I have all these names and also their counts. So just to see this working, I could add something right now where I'll say insert into users values. I'm not going to give it the ID. I'm just going to say it has a name of John Doe. So it has an identical name. And then I'll also give it an email. Why not? Exactly like this. And I don't really care. So I'm just going to give it this exact timestamp. That works for me. So this is enough to put in there. I would assume it would have auto incremented, but you know what? We're just going to say, okay, this is the 5th person in this row. Okay. And now if I selected star from users, I would see there are 2 John Does. So now if I go back here and I say, okay, we're selecting the name and the count of name, group by name is going to take everyone with an identical name. So it's going to take both John Does. It's going to combine them. And so now when I say select name, it's only going to print 1 John Doe. But when I say count of name, it's going to say how many John Does got grouped together. And in that case, we see there's 2 John Does. And, you know, we might combine this where I say, okay, that's the count of the name, but I don't necessarily want to call it count. And I'll say as, you know, number with same name. I bet it doesn't like this because I bet I'm going to have to combine it in quotes like that because that hash is probably a key thing. Yeah, it doesn't like that at all. I'll just say num. Okay, so now we combine those. Now we have the names of people, and then we have a column called num with same name that represents how many people had that identical name. Okay, any questions on that? Some of this assessment is asking you to like learn certain things. So we're going to expect that you use count. We're expecting that you're going to use sum. There's going to be this group by, you know, the difference between joins will matter a little, but only really in the order that you look at things. This is an important one. If I were to try and find something where something was null, so let's say I, you know, had something like this. Let's add, again, let's, just to see an example, I'm gonna say select star from users, and let me add a user with some null in there. So I'm gonna say insert into users, and what am I gonna insert into users? Some values.
I
And
think the
yeah,
values may all be not null, so I'm not,
that's true, yeah.
just to warn you.
Yeah, no, that's a good point. The only reason this null is gonna come up is because there are ways of joining things such that it's not in one column, but it is in the other, and so you'll get a null that way. And the point of this is just to say that I discovered this myself. Writing where ID equals null does not work, because as it turns out, nothing is equal to null. That's how null works in SQL. Instead, you write where ID is null, and that checks if something is the same thing as null. And the only other thing here that you might want to know is that, let's say I came back here where I had this, count thing. So I'll just bring that back to what it was. I'm saying select name and the count of the name from users group by name. That's going to return me all of my names and the count of all the names. So let's say I wanted to return a situation where I only wanted to include, let's say I'm just going to say name, right? So I'm not even going to mention the count of the name, but I actually care. I'm going to say, let's say name and email. Is that right? Or okay, got it. Yeah, I can't do that. We're just going to look for the name. But I only, so right now this works. I'm getting the name of everybody, but I'm saying group by name. Why? Well, I actually do want to group them. And then what I want to add to this statement, I messed that up. Give me a second. What I want to add to that statement here is I'm selecting all the names from the users. I'm grouping them by their name. And then I want to say something like where, I could have said something like where name is equal to John Doe, right? And in that case, what went wrong here? Maybe it's name like, but no, it doesn't seem to like.
Maybe the group by has to go at the end after the where statement.
It is possible. Yeah, that's likely the case. So this is a different example, but I'm showing you I have two John Does there. If I go back here, I'm grouping them by name because I want to use count, right? So I might think I could say something where I might want to write something just like I wrote it at the top before. Instead of writing count of name at the top, I want to say where the count of name is greater than 2. So unlike this up here, I don't want to see everyone's count. I want to see only the person whose the count of their name is is greater than 1. Okay, so that is not going to work. And the reason it's not going to work is hard to read, but it's because if you're using a group by and an aggregate function like count, instead of where, you want to say having. It's just a different keyword, but that will now work where it's going to return only the people whose count is greater than 1. So these are all the things that we might want to know about. That's everything I wanted to cover during this. What I mostly wanted to cover was just walking through that flow for seeing your grade generated in real time. But let me check our schedule. I'm pretty sure based on our schedule, all we have right now is this end of day form. So I'm free to stick around and answer questions on things, and to talk more about, anything you might want for the assignment, for the assessment. But you're officially free to go at this point, and only to the degree that I can be helpful to you should we continue. But I'm sure you have questions.
So I have a question. So that having, you said that you use that when you use more than one aggregate statement. Is that why you have to use having versus if you just use like count one time and nothing else, you would just use where?
No. So the thing is, if you're going to do an aggregate statement, first you have to group things. And then that means that whether it's in this select part or whether it's in this having part, now you can use an aggregate function. So the difference here is like, I'll start again with a simple thing. So we're starting with select star from users. So these are all of our users, and I could right now just say something like select star from users, and then the next thing I write is where, and I might say where name is like, and I'll say where it's exactly like John Doe. In that case, I think I could just say equal, right? If the name is identical to John Doe, then that's going to return me all the John Does. And of course, if I said something like over here, that gives me access to this percentage sign, which will give me all the people whose name starts with John, period. So that's 3 people now. So that is when we would use the where. We use the where when we want to make some, when we want to filter the data in some way based on something directly in the table. We use having when we want to do something with an aggregate statement. So now we're going to go back here and we're going to say, okay, that's everyone from users. But what if I wanted to take everyone from users and I also wanted to know their, like the count, and I wanted to know the count of, you know, everyone by name. So I wanted to know everyone with the same name. So that's not going to work. And it's saying it won't work because, oh, interesting. I think, well, let's just say I said the name, I wanted to know the name and the count by for everyone with the same name. That's not going to work. And it's not going to work because it's saying name has to appear in a group by statement if you're going to use it in this aggregate function, which is what count is. So instead, I'm going to say I want the name and the count of everybody from users. But before I can do that, in order to get access to the count aggregate function, I have to group everybody. And what am I grouping them by? I'm grouping them by an identical name. And now I got everyone and the count of their name. Now here's where having comes in. I'm already grouping people, right? And I have their name and their count. But let's say I want to filter this just like I used a where. Well, I actually don't want to filter that in the way I used where, because where can't deal with aggregate functions. I'm pretty sure it's because, you know, aggregate functions and having were a later creation. So now instead of saying where, I could say having, and now I could say having, and now I have access to that count. And then I could say, instead of like having, you know, name equal to, or instead of saying where name is equal to John Doe, I could say having count of name, you know, identical to 2, let's say. And now that's going to do filtering, but using that aggregate function.
Okay, thank you.
That seem good? Ethan?
Let me lower my hand. So is the testing function of GitHub testing the query, like getting the output? Like if the output's the same, then it's good, or does it have to match the exact query that you have in the answer key?
So we don't care, like, I looked at Francisco's answers. He wrote the queries differently than I wrote them. However you write them does not matter. What matters is that when you run the query, you get certain output, and that output matches exactly the output over here. So in each one of these things, we give an example output. And if you look in the README, we give the example output again for each thing. As long as the output is identical, it will pass the test. And I mean, we're going to use the autograder as much as possible, but if people say, hey, my thing should pass the test, it just like, for whatever reason, I wrote it in such a way that, you know, computer is now not the first thing, but it's the second thing. Well, that would fail the test because the test is a little specific like that. If that's the case where you believe you should have passed because it's the same data, but it's not passing the automated test, you just let us know after you submit, hey, I want you to manually grade mine. By default, we're not going to manually grade people unless we get feedback like that, and or someone has a failing grade, and then we are always going to directly look into it. But by the nature of SQL, I don't see how that would happen. However you write the query, you should get the same data back in the same order, but it could happen.
Okay, yeah, I just want to make sure. Thank you.
Cool. All right, anything else? Love your shirt, Grace.
Hey, thanks a lot for the recap, Ben.
I got a quick question. Was it Postgres or was it Django that didn't want to do the many-to-many connections?
Say that one more time.
Was it? I can't remember. I think it was from earlier. I think was it Django that there was no way to set up a many-to-many connection in Django, or was that something that was a limitation of Postgres itself?
If that happened like today or yesterday while Francisco was teaching, he might know more about that than I would. Because I mean, it could have been either. It could have been that Django couldn't handle it. It could have been that SQL couldn't handle it because it wasn't done right. I'm not positive, but many-to-many connections are definitely the most complicated type of connection, and there's none of that on the assessment. So
if you would like me to
assessment,
answer.
yeah. What was that?
Oh, okay. I was saying I'm here if it's okay with you, I could answer that question real quick. Yeah, so the many-to-many relationship is strictly handled in Django. You can't really build a strict many-to-many relationship in Postgres. In Postgres, you would have to build a connecting table in order to be able to have a many-to-many relationship.
Okay. All right. That makes sense. All right, cool.
Yeah. And the only thing that our examples do, as you'll see, examples doesn't really matter. Items here, you know, it's not referring to anything outside of itself. Users is not referring to anything outside of itself. Items, again, is not referring to anything outside of itself. Orders refers to a user. That's it. So each order can refer to many users because one user could have multiple orders. And then order items is such that each order ID is associated with one item ID. So actually, I guess this is many-to-many in that we have the same order here referring to multiple items. And then we have multiple items in different orders. But it's you don't need to set any of that up yourself. All you need to do is copy this data from the CSVs into your tables. And then from there, you'll be able to query on it. But we're not asking you to create anything. We're just asking you to copy all the data from a table or from the CSVs into a table you define. And then on your end, while you're making the schema for the table, you might want to use like references to say, oh, this isn't just a random number called order ID. It actually refers to the ID of this table called orders.
So there will be no creating the middle table, the reference tables.
Exactly right. The middle table has been created for you. It's called order items. It associates orders with items. It's just something you fill in the same way you do the rest of them. So this type of code is going to be identical, and all you're going to change each time for each one of the tables. I'm noticing, yeah, orders should be here too. There should be a section for orders. But what you're doing each time is you're just going to say like drop that given table if it exists, possibly Cascade, then define the table with, the right column names, types, and constraints, which might include reference type constraints. And then you're going to copy all the data into that given table. So like, yeah, once we created the table for order items, we would just copy into order items all the data from order_items.csv, and it would all work. And then you could, write queries against it.
You had me at it will all work.
Yeah. I mean, we'll see, of course, but in the end, it'll all work.
Right on. Thank you.
Cool. Anything else? When we're done, I'm going to upload this to YouTube and then I'll share it on Slack.
Thank you.
Thanks, Ben.
Thank you. Thank you for listening.
Thank you, Ben.
Sign
Quick
us off.
question, because I keep finding different versions of this, and the ones I'm finding aren't working. Could you refresh my memory on the syntax for a foreign key? It would be, for example, if I have two different tables, one is a bookcase while the other one is a book. If I'm trying to reference the book to the bookcase, let's say I'm trying to get I would have the bookcase ID in the book table, and I would put foreign key bookcase ID, or would it be book references bookcase? How would that be?
Well, I'm happy to do that right now. So given that you've come up with an example, I'm happy to write it right here. So, this is where we would fill in our actual stuff, but we can put other stuff here. So I'm just going to create some tables here, and I'll say, something like drop table if it exists. And the two things you said was
Let's do bookcase
bookcases
first.
and books, right?
Mm-hmm.
So I'll have a table called bookcases. I'll first drop it. And then I'm going to create what a bookcase looks like. And what does a bookcase look like? Well, it should definitely have an ID that is serial and primary key. And then let's just say our bookcases have a name, right? So, the name could be something like fiction or something. And then books that are fiction books would be associated with that bookcase.
Mm-hmm.
Cool. And that's all we need for our bookcase. And then maybe because we want some examples, I'll just use insert into. And I'm inserting into bookcases, values. And then I believe I can write it like this, where I could say okay, well, the ID will be generated automatically, I believe. Didn't seem to work last time. But then I'm going to give it a name, and the name will be fiction. And then I'll give it another one that looks like
Nonfiction.
Nonfiction. Sure, there's only two types of books. I think that's enough. So let's see if this works when I run it. So let me exit out of this. So now I'm going to run my create schema thing. And did it work? It did not work. So can anyone tell me, do I need a comma here? I always forget the exact syntax. That's probably what I need.
I think after bookcase, you need to put a parentheses and put a name in the parentheses.
Yeah, exactly right. That's a good point. So the reason is it's expecting me to give everything otherwise, right? So now this should work. Great. And now if I went into PSQL, I went into PSQL, the name of the database, and I said select star from bookcases. Great. I have two types of bookcases, fiction and nonfiction, and it works. Okay. So now what we're going to create next is books, right? So I'm going to copy the exact same thing. We'll obviously change some of this, but now I'm going to say drop table if it exists, books. And I'm going to name this table called books, and we'll update it. And eventually we're going to ignore this for now, but we're going to want to create some books to fill in our database. So let's start thinking about this. So a book is going to have an ID like normal. Let's say it also has a name, because, book's going to have a name. So my book is going to be something like, looking at my own bookshelf, I have a book called Dune. I could also add the author if I wanted, but we're not going to worry about that for now. We're just going to we just want to care about what bookcase is this associated with. So first, what should I name this foreign key? What should the name of the column be if it's going to refer to a bookcase?
Would it be bookcase ID?
Exactly. Yeah. And it doesn't matter, but it is nice to do that standard naming scheme, because you're saying, okay, every book belongs to a bookcase. Great. So it belongs to a bookcase ID. What should its type be?
Integer.
Exactly, yeah. So it's ultimately referring to a number, and I guess to follow the pattern I've been using, I'll make it capital. So it's going to refer to, if we get this back and I go back in here and I look at my bookcases, it's going to refer to 1 or 2, and those are numbers or integers. So cool, it's an integer, and maybe I'll say that every book has to have a bookcase ID. Maybe I don't want that to be the case, but yeah, forget about it. We're just going to say every bookcase has an integer, but maybe that turns out to be null, because maybe this is a book that's neither fiction or nonfiction, just doesn't fit into either category. No, yes, so we're going to ignore that part, but now we want to hook it up to bookcases, right? So the way we do that is with the references keyword, right? And the way the references keyword is going to say, okay, what does it reference? And anyone correct me if I'm getting my syntax wrong, but I'm saying bookcase ID references something. What does it reference? Well, I'm going to take bookcase ID and I want to make it equal to this table called bookcases, which has, can it remind me, is it .id here or is it parentheses ID?
I think it's parentheses.
I think it's parentheses, yeah. So bookcases has something in it called ID, and I'm saying bookcase ID is going to refer to bookcases ID. And because I set it up this way, it's going to get pretty upset if the ID I gave it does not already exist in bookcases. So let's try this out as it is before I add any unique items. So I'll take that out for now. Or maybe I'll even comment it out. Maybe that's a little simpler. So we already have fiction and nonfiction, but we're creating this table books. And when we add bookcase IDs to it, we would want them to actually be something that exists in bookcases. So I'll try that. And I guess I'm already in here, so I can say /I create schema. That seemed to work. And now if I say select star from bookcases, that's still there. But if I say select star from books, okay, it looks right, but there's nothing in there. So let's try and insert some books in. And my books have a name, but I'm also going to give them a bookcase ID, and their own ID will be auto-generated. So I'll give it some books in my library. I see I have Dune there.
Great choice, Ben.
Thank you. I haven't finished reading it because I saw the movie. That's a bad approach. Ooh, I got some good books, right? I got Is This Anything, which is a book by Jerry Seinfeld. And let's just do one more. I have something called well, actually, let me see. So Dune is fiction. Is This Anything? I don't know. I would call that nonfiction. So we have all of our topics covered. But yeah, I'm gonna say something like doesn't really matter at this point. I have something that says it's called DC Comics, The Art of Jim Lee. Cool. So now I'm going to give each one of those things a bookcase ID. So Dune, which bookcase ID should it get? Remember, these are our bookcase IDs. Dune is fiction, so I'm going to give it the bookcase ID of 1 to associate it with the fiction bookcase. Is This Anything? Is Jokes by Jerry Seinfeld? Is that fiction? Is that nonfiction? I don't know. We're going to say that's nonfiction. So that's going to be associated with the ID of 2. And then because I said that things can theoretically be null, well, what is an art book, right? Is that fiction, nonfiction? It doesn't really make sense to consider it either. I'm just going to say for this one, it's null. And because I didn't use the not null constraint, I think that should work. So I'm going to try running the file again. Oops. I'm going to run the file again. And that seemed to work, but we have one error. I cannot drop table bookcases because other objects depend on it. That's right. So it's over here, I'm trying to drop bookcases. Sorry, over here, I'm trying to drop bookcases. But the problem is that this later table books, which already exists in our database, it refers to bookcases. So in order to fix that, I just add the cascade here, which means that while dropping bookcases, it'll also drop anything that refers to it. So it'll drop, you know, our first 2 books that directly refer to bookcases. I'll try that again.
Do we put it there? Or is it on the drop table portion of it? I don't.
Oh, great point. No, I put it in the wrong place. You're absolutely right. Doesn't make sense there. Great point. Yeah. So it's telling me my error is on line 36. It can't drop it there. It's even giving me a hint. You probably want to add Cascade, and we want to add it where we drop it. Good catch, because that what I did would not have worked. So we're going to run that again. And now it appears to be working. We get this notice saying what it's doing. But now if I look, it's recreated everything. So I'm going to look at my bookcases, still what I expect. Look at my books. Okay, so now I have a book with a given ID and a name and a bookcase ID, and that all works. But of course, if I tried to say insert into, and then I tried to say insert into books, values, oh, right, and I want to say just the name and see what I did here, just the name and the bookcase ID. So those are the only two things I'm providing. Let's say I'm going to try and add a new thing to this table. And the book I'm going to give it has the name. One more book I have here is called 10th of December. And that is definitely fiction, but let's just say I'm like, oh, well, this belongs to a bookcase y'all never heard of, bookcase 3. If I try that, it's going to say I can't do that. And that's because by the nature of this foreign key constraint, it's not going to accept any old integer. It's only going to accept an integer that exists already in bookcases ID column. So that ensures that if we ever try and associate these things, we can. And so one way we might associate these things is I might say select star from books. And then from there, I might say, you know, inner join with bookcases on, and then I would say how they're related. And in that case, I would say books. I think I want a dot here, right? Books dot bookcase ID is identical to bookcases dot ID. And let's see what that gets us. Great. So that walks into books. It saw all these books, and then it tried to associate each book with this table bookcases. And so anytime there was a matching bookcase ID in that table bookcases, it combined them. And so that's why we have all this data here. And, you know, maybe we would clean that up by saying, we don't want all these IDs. We just care about each book's name. And, oh, interesting, because of how it is, we might have to say something like books.name. And maybe we would call that something like book name. And then after that, we would have bookcases.name. And we would save that as something like category. Now, when we print this, we get something like that. Yeah, and the only last thing we might want to show is something about, okay, so this was using an inner join, which means that every time, you know, we started with the table books, every time the book had a bookcase ID that existed in the table bookcases, it matched them up. But what about for the null? Well, in that case, if we want to make sure that we still associate DC Comic, that we still want to have DC Comics, The Art of Jim Lee, we still want it in our final table, even though it doesn't have a meaningful bookcase associated with it. In that case, instead of doing an inner join, we would say something like full outer join. And now it's going to associate everything in books with what is in bookcase ID. But if what is in books has a null bookcase ID, it still appears in the table.
Awesome, thank you.
Cool. All right. Anything else, or should I upload this? Okay, if there's nothing else, I'm gonna sign off. Thanks, everybody.